Hello. Good morning, or good afternoon, or whatever time it is for you. Hopefully I am live and everyone can hear me. Hey Laszlo, welcome. Wario, good to see you. Gonna let a few more people trickle in just to make sure. Florian, nice. Hello. Nice, looks like we've got lots of people now. We got Kane, we got Paz, hello, hello. Zion, good afternoon to you too. It's morning here, but... Hey Friar. Yes, indeed. This one has jumped the queue, and I think you guys won't be mad about that. In fact, I added it to the queue myself because I have a deep suspicion that if not today, very soon, CTC will very much want to feature this because it's actually incredible. I keep my puzzle cube private so that I don't have people talking to me about it. I like to manage it myself. Pause. I mean, I don't think there should be a reason to be scared to submit your puzzles, but you don't have to submit your puzzles if you don't want to. Everyone here is very kind, though. However, if you are concerned that I have lost your puzzle or that your puzzle should have been done by now, and it's been 2 weeks since you submitted, feel free to just ping me about it and say, hey, are you still, is my puzzle still in the queue? Are you still gonna do it? And I'm happy to answer those questions. More recently, I've been doing the queue in a more systematic way, so hopefully fewer puzzles will be lost or like sitting around for a month. Yeah, I dread the day that I get more submissions than I'm able to get through, and I actually have to pick and choose like CTC does. Do I still solve puzzles and setters don't show up? Yeah, so I've started doing that. Basically, I will respect the day that was requested. So if you request specifically for a Thursday or Saturday stream, I won't do it on the wrong stream. But at this point, I'm just going down the list. So if you can always watch the VOD. If you aren't able to watch live. What I will do is if I don't see the person in chat, I'll just give them a little ping, or hopefully one of the viewers will, and let them know that I'm solving the puzzle. Speaking of, I will ping Philip. He's usually busy. He's got the kiddos, but I'll let him know. Luckily, with more viewers also comes more support. So if I do need to end up offloading the queue to the community, then I will do so. But for now, I just manage it myself, and it hasn't been too bad. it's kind of a good problem to have too many submissions. All right, so I think this has been enough time to let people filter in. I'm going to give a little backstory on this one because it's actually pretty incredible. Look how sparse this grid is. I don't think you've ever seen a. I think there's partial killer and then there's this, which I think should be a new category of like minimal killer. But Philip has called this White Room. And if you are on the CTC Discord and you at all visit the Theory and Programming channel, this won't be a surprise to you because he's been working on this for a few days now. And basically the question popped up of not what's the minimum number of killer cages, but what's the minimum coverage of killer cages to make a unique puzzle. And very smart people in theory and programming, pretty much, I think there was one outlier, but most people agreed that it would probably end up somewhere in the mid-20s in terms of number of cells, because a killer cage just doesn't give as much information as a given. And so for a classic Sudoku, you must have, that's been proven by computer, that you must have at minimum 17 given digits. So if you kind of think about that and you kind of do the math in your head of, well, a 2-cell killer cage is about half as much information as a given. So I'd expect 34, but, you know, there's probably like synergy between them. So maybe, you know, 26, maybe 24, like somewhere around there would be kind of an initial guess. And previous to Philip's work, the lowest he'd seen coverage was 34 cells, and I think Sam Kappelman Lines had seen 31 cells. I did like a randomized search as an attempt to answer the question. I found, I think, 26 or 24 coverage. But then Philip started working on it manually, using a solver, my solver actually, to speed up the process. But he manually placed the cages and twiddled with them himself over the course of a few days. And he kept getting it lower, 21, 19, and then finally this one, 18. And this was actually not only the first 18 he found, but it's the first one that has an interesting solve path. All the other ones were actually quite easy. But according to people who solved this, this is actually quite a nice puzzle as well. So I would like to solve it. So if we count here, we have 3, 5, 7, 9, 12, 14, 16, 18 cells covered by killer cages. He is trying to get to 17. The fact that 18 exists has really motivated him. I think he's taking a small break from doing that. But he has a 17 with 70 solutions. That's his best so far. It may not be possible to get to 17, which would be unfortunate, but he's going to try. And that would be awesome as well. So, yeah, that's the backstory. And the rules are, in case you aren't familiar with Killer, we have normal Sudoku rules, and then digits can't repeat in a cage. It's only relevant to this one here. So if I put a 9 here, I can't put another 9 here because that's in the same cage, even though normal Sudoku rules would allow that. And also the digits in a cage sum to the value on the top left. So these 3 would add to 23. So yeah, let's get started. We've got a bunch of automatics. So this 3 is a 1, 2. The 17 is an 8, 9. It's the only way to do it. 5 is from 1, 2, 3, 4. 6s are either 1, 5 or 2, 4. You can't do 3, 3 because that would repeat, and no, you can't do that. 15 is either going to be 6, 9 or 7, 8. 23 is 6, 8, 9. That's the only way to do that. And 7 is always 1, 2, 4. So these are our kind of obvious marks here. We certainly do want to link you guys, so let me do that. I always forget to link. So, pin that for you. All right, so did that pin? It doesn't show up on mine. Anyway. This 8-9 pair gives us the 6 immediately. So the 6 can't repeat in the cage. We have an 8-9 pair here, so this is not 8-9, so that's not 6-7. What do we know about the 17 digits? How many of each? 2 sets of 9 minus 1. We don't know what the makeup's going to be. The one with 70 solutions actually has a good mix of 3 size and 2 size cell cages. Yeah, you can only pin one of them. So I pinned the CTC one. This is a 3 out of 5 according to Discord. So it doesn't just collapse immediately. From what I heard, it did take some thought. So that's why I wanted to feature it. Do you mean 17 givens? There are 49,000 known puzzles with 17 givens, and I don't think there's any significant pattern to them. That's 49,000 non-equivalent puzzles. Obviously, there's all sorts of ways to morph and translate puzzles that are essentially the same as each other. Cells, row 7, column 1. Aha, yeah. So we got the 1, 2, 4 looking down, the 1, 2 looking over. So we kind of have a hidden 1, 2 over here. That's a good thing to look at. The 8, 9s, we got an 8 and 9, oops, limited over here. In columns 6 and 7, the 5 and 6 cages use 1, 1, and 1, 2. That's a good point. So does it use them all up? Ah. Yeah, so we got this 1, 2 pair here in both of these, and then so I guess the question to ask is how many 1s and 2s can you put in these columns? It's not a trick question. You can put 2 1s and 2 2s. So this accounts for 1 1 and 1 2. We only get one more 1 and one more 2 in these columns for the rest of these cells. The 5 is going to use either a 1 or a 2, and the 6 is going to use either a 1 or a 2. So that's it for it. So we can't. This one can't be a 1 or a 2. Neither can any of the rest of these columns, which means that this one is a 1 or a 2. Columns 6 and 7. So one of these is going to be 1 4. This will be either 1 4 2 1 4 2 4, or it'll be 2 3 1 5. Coloring 8 9s. Yeah, let's. I was just looking to see if there was anything. This 6 cage must interact with these in an interesting way. The 4 5 here. I don't quite see it though. Yeah, let's try coloring then. I'll use green and purple for them. This is 1 4. This is 2 4. This is 2 3. This is 1 5. Green in box 9. Aha. So this is an 8 9. Feeling where green goes. And then okay, this is useful. 8 9 here. Green is in one of these. That's not as nice. But the center box, one of these. So this could be useful that green is limited to these two. Oh, wait, yeah. Look at this box. Green is here. That puts a green here. This is an 8-9. And so then this one has to be green for the row. So these aren't green. Are we going to get all the greens? We still don't know what it is, but we know where they are. So purple is one of these two. I don't need the corner marks if I know it's purple. So that actually places this purple. And then purple's here. And here somewhere. It's here somewhere. It's one of these four. Box 8 is fixed. Oh, we have these pointing down, right. I didn't see that. So now, does this help? Yes, that places this purple. Oh, that's perfect. Because that comes back up here, places this one. And that places this one. And yep, we get this one and this one. So we have all our purples and greens now. What's that do? How are they going to get resolved? They must resolve, right? It's going to get resolved by the 15 cage is the only thing that'll do it. So we'll need to do it by getting this 6 or 7. So yeah, let's color this one blue. It has to go here. Playmaker. Don't know if this was an intended path. There may not be an intended path for this puzzle. It's more of a discovered puzzle given its minimality. So it's all about however we'd like to solve it. What I do, oh, okay, that's obvious then. That this is a 7. So I don't need to color that anymore, and we actually know that green is now 7 plus 8 is 15, that's good. And we got those done. Uncolor that. This 6 was looking at this blue square. Okay. So, is there anything more we can do with 7s? Column 6, let's take a look. Ah, that's a good spot. We got a hidden 7 in this column. Doesn't... Oh, here. Places that 7, that 7. Oh, there's a 7 in one of these two. And there's a lot of places for 7 in the bottom band, unfortunately. Well, maybe not here. Okay, 7's here. Let me look again. Any of these? Yeah, we got this formation of 7s here. I won't mark that. What else do we have? I still haven't really figured this out. I think I'm gonna have to. I don't think that anything else is gonna resolve the 1, 2, 4s, and 5s. Oh, I can place the 6 here now. The 6 looks up. These 6s look down, so there's a 6 in one of these 3, which I will mark. 6 in one of these 3. There's a 6 in one of these 2. One of these 3. One of these 2. And this is the 6s line up here. The 6 can't be in this. Yeah, I guess a hidden 6 in the column would be the way to put that. 6 can't go in any of these, and it can't go here. That's because of the 6 here. So 6 goes there. It gives us this 6 and that 7. Very nice. This column just keeps giving in terms of hiddens. What do we need that's not... I guess it is just 1, 2, 3, 4, 5 that's left for the column. We don't really know anything about those digits yet. Did I finish the 6s? I feel like I did not. I didn't. So that didn't actually help with this last pattern of 6s here. And then we got these. Ah, this can't be 6. We got these 6s like this. Let me just highlight that real quick to see if there's... Does this skyscraper do anything? Don't think so. Alright, well, I'm going to mark these 6s and move on. So, hey Mikey, how's it going? One, 2 hidden in box 4. I'm not seeing it. We know these can't be 1 or 2. So these are either 3 or 4. Wait. 3, 4, or 5. We learned that very early on. And then this one can't be 1 or 2, so it's 3, 4, or 5 as well. Okay, fill this candidate, 3, 4, 5. And this is 3 and 5. We got a 3, 4, 5 triple here. So this is 1, 2. Ah, yeah, so where do 1 and 2, this 3, 4, 5, yeah, so this is a 1, 2 pair. There we go. That's what you were talking about. There's a virtual 1, 2 here, so we can't have any more 1, 2s here. So these are from 3, 4, 5, 6, and this one can't be 6. I don't have any placed 1, 2, 3, or 4s or 5s though, so I need to figure out how that's gonna work. There's a 4 in one of these 2, so these are from... Ah, so where does 4 go in this column? That's gonna place a 4. It goes here. There's a 4 over here. Come on, what's this 4 do? What's the 4 do? These are from 1, 2, 3, 5. I got a 1, 2 pair here. So these are from 3, 4, 5, 6, but these aren't 6. So that's 3, 4, 5. So this is a 1, 2. That's a 1, 2 pair. These are 3, 4, 5. This is a 1, 2 for the row. We have a 1, 2 in the column now as well. I guess 7s are in this X-Wing. I was looking at 7s real briefly. Alright. So we have 1, 2. We need 3, 4, 5, and 7 here. Ah, not 4 though. So 4's in one of these 2, so it's not here. Yeah, I'm gonna color. I think I wanna can this be 1 or 2? This is a 1 or a 2. If this were a 1 or a 2, then this would be a 1 or a 2. This is not a 1 or a 2, then this can't be 1 or 2, so. Alright, let's... I think we can color the 1-2s now. I'll just use green and purple again. Purple, purple, green, oops. Green, purple. One of these is green, but I don't know how to mark that. Do these not extend? Ah, here we go. Here's a green. Purple. Green. Purple's in one of these two. Ah, but this can't be purple or green. There we go. So this is 1, 2. And that helps because this is now 3, 4, 5. And then there's a green up here. Okay, this is purple. There has to be a green somewhere here. So this can't be 1, 2. So that's 3, 4. This is purple because we have the purples looking in. Fix that green. I guess that would have been more direct. There's a purple in here, which means there's a green up here. Do we know what this one is? Definitely a neat puzzle, for sure. You're saying this one's green? Oh, it sees a purple. What am I? It's the bottom row scanning that always gets me. I have to look. So these aren't green. This one can be purple, I think. Or this one. No, not this one. It's this or this for the row. Oh wait, but then in this row, where does purple go? Ah, purple goes here in the row. So then this must be purple for this row. And we get a 4 here. Ah, that's... look at that. Look at that 4. So we got 5, and all the purples are 1. All our greens except these are 2. And I'll just mark these as 2s, and we'll get rid of our colors. This is huge. Alright, so that's a 2, 3, 5. This one's not 2. I guess I don't need those corner marked. Oh, we have a 5 in this row. So 2, 3, 6 is what's left here. This can't be 2. This is 3 or 6, and this is 2, 3, or 6. Did I get all the 1s and 2s? No, there's no 2 in the center box here. That goes here. That takes place of a 6, but we have 2 left still. Oh, and then we get this gauge as well. So this is a 3. That's our first 3. That's 5. What else does the 3 do? That's not 3. There's a 3 in one of these two for the column, which means these aren't 3. There's a 3 here, so that's not 3. And that's not 5 either, so this is a 4. That's a 3, 5 pair, so these aren't 5. So that's a 4, 6 pair, so these aren't 4. 3, 5 pair. These are 2, 4, and 6. Four, 6, 7's what's left here. So it's just 2, 3, 4, 5, but not 2. Okay. 3, 4, 5. We have another cage. Jeez. I need to pay attention to these cages. I think that's the last cage though, so it should just be Sudoku from here. 3 and 5. So this can't be 3 or 5. This was, I think I agree with the 3 out of 5 difficulty here. This was a cool puzzle. I liked that. I assume it just will cleanly solve at this point, but 3, 4, 6. Maybe I still need to do some coloring actually, or did I speak too soon? Oh shoot, I didn't mean to do that. I just wanted to clear my corner marks just to have less distraction here. Since I'm fully marked now. I'm probably just missing some kind of scanning. Can you imagine if there was something like an exo set at the very end? The fin jellyfish. 3 overlapping fin to jellyfishes or something. Okay, there might be something interesting to find at the end here. Let's look at buy values maybe. There's a lot of buy values. Do I color? Maybe I'll color 3 5s and see where that leads me. One of these is green, one of these is purple. This is purple, one of these is green. This might not be as helpful as I thought it would be. Okay, well, this can't be purple, because, wait, no, it could be purple. No, it can't be purple because he's purple. So purple's limited up here. Does that help? Oh wait, purple could be here. Never mind. Maybe this wasn't the right thing to color. Is coloring necessary? I don't know. I didn't see an immediate. Ah, we do have this hidden 5. That'll help. In the box. That does not place this 5. What am I not seeing here? Don't think that's gonna eliminate anything. Needs to cross boxes. 4s are here. Maybe I should just highlight. I'll highlight where 3s can go to start. Just to do something. I'm sure we'll find something. No? Alright. Yeah, I was gonna do buy values and then someone suggested coloring. I'm just gonna go through the numbers first to see if there's a pattern to find there. And then I'll look for wings. I just want to see what the cleanest way to get through this would be. Sticky ending, though. I mean, we got all sorts of, like, useless kites. You're always going to find those, though. I don't see it. Fives? Is that it for fives? Looks like it. Alright, let's look at buy values then. So many. So 3, 4, 6, does that... No, they'd have to share a box, but this 3, 4, 6 maybe. No. This 3, 4, 6? No. Row 1, column 6, row 3, column 4, and row 4, column 4. It doesn't... Ah, here we go. So here's a Y-wing. Let's use orange here and blue is here. If the orange is 3, this is a 4. If the orange is 6, this is a 4. Either way, at least one of these two is a 4. And they both see this cell here, eliminating 4 from that cell. So this has to be a 3. This is 5, 3, 5, 3, 4, 6, 4. Just follow these around. It makes this a 4, so they're both 4. 6, 7 pair, that's a 3, 2, 3, 6, 4, 2. That 6 sees up, 6 and 7, and this is 3 and 7, and there we go, we solved it. Sticky ending there. It only took a Y-wing though. It's yeah, it really is an extraordinary puzzle. Like just finding one with 18 coverage is incredible. Even if there ends up being a 17 coverage one, this is still incredible to have 18 coverage. And then not only that, but the solve path was quite intricate. Very, very cool. We had to do coloring a few times to disambiguate, like find where all the 8 9s go, find where the 6 7s go, and then the only way the 8 9s disambiguated was by coloring this cell and discovering that it had to be in these locations, and this given, I mean, it's not, it's basically a given 6 here. This given 6 saw that, making these 7s, and then that disambiguated all the 8s and all the 9s. That was really cool. And then we just kept going on the 7s and 6s, placed most of those. The even just the logic at the start, where this was a 1-2, and then the 1 and 2 were used up, that was very cool as well. Simon's gonna go nuts over this if he does it. He's gonna love it. All right, so I think Mark would love it too. But my prediction, Mark tests it and then makes Simon do it right away. That's my prediction, but we'll see. Yeah, finishing on the Y-Wing, like, oof. But I hope you guys enjoyed my solve too, and don't just hope for a CTC solve so you can enjoy it. But I really wanted to finish it without looking at chat, but it was taking me too long to find the Y-Wing, so I looked at chat. Okay, so let's move on a very complicated rule set on this one. Oh yeah, if Mark puts it in the software and says don't look at it until like the miracle style, like I think Simon has done so many partial killers that he has an idea of how many cells are covered by killers, and just if I just open this again, like, and I clear this out, how does that even, like, the brain goes, there's no way, right? It looks so sparse. How could this possibly solve? But yeah. So the new puzzle is pinned. And this is There's Something Missing by Is it Qinlux? It must be Qinlux, right? I always want to say Qinlux, but there's no U there, so I apologize to Qinlux or Oh yeah, like if it were anti-night or some other global constraint, then yeah, you would definitely go, okay, yeah, that's expected, but like you look at it and go, is there a rule missing? Sorry, I can't stop thinking about that puzzle, but now I've solved it, and I'm happy that I solved it before CTC had a chance to feature it. So, because in between it being published and CTC's next video, that was my window of time to be sure to solve it before them. So this is just a classic Sudoku. There's Something Missing by Qinlux, and how should I get started? I guess I'll just mark hiddens to start. I'm certainly seeing a pattern here. Don't worry, I see things lining up, but I like to start with the obvious stuff if there is anything obvious. We're not given a whole lot though. 4s are there. 2s are there. 3s are there. Look at this. We know nothing about this column. That's really interesting. Okay, well we've got maybe it's not so bad. We got 8s there. What other 6s see down here? Okay, so the 6s here. 7 in this box is here. So 7s are here. That was from this 7. We actually have a lot of 8s. 8s are here. Let's not talk about complex stuff yet while I haven't even looked for it. Especially with classics, I like to start without help. Let's see. Did I miss any? You can tell me about any like hiddens if I'm missing any of those. Like basics. I don't mind if you tell me about those. Yeah, I'm suspecting something fishy going on here, or something set, or almost lock sets. Like just from the alignment of the digits alone. And the title, "There's Something Missing," implies ALS. Okay, so I'm going to actually look at these weak columns and fill the candidates. What do we need here? We need 1, 2, 4, and 9. That's not 9. Oh, that's not 9 or 2. That's not 9. So 9's one of these two. Do I not have... Okay. These 4 are 1, 3, 5, and 7. This is not 7. These aren't 5. Okay. We also have these triplets here. This triplet is 1, 3, 7. That's not 7. That's not 3. Whoop, typing the wrong numbers. That's not 3. Row 8, column 4. I missed. It's not a 4. Okay, there's a 4 in the box there, and oops. And this one's not a 7. Okay, thank you. The also down to 3. Thank you. So we kind of have this interesting buy value sell, and then no, they look like they're set up similarly, and that seems purposeful. Obviously, if we take any 3 of them, it's an ALS. Let's see. 1 is the common digit between them, and only 1. 2 in box 3. Oh, we just get a 2. How did I miss that 2? Three's in one of these 2. Should I... There's these ones as well. Let's just fill these columns. We need 1, 6, 7, 8, 9. So this isn't 8 or 9 or 6. That's only 1 or 7. That's not 7. That's not 9 or 8. This isn't 6 or 9, and this isn't 6. And then this column here, we need 1, 3, 4, and 6. It's not 4. That's not 6. That's not 6. Hey, Davis. And then 5 is limited here. Box 3. Even just looking at our marks. Puts a 5 in one of these two. I'm wondering if I should draw some kind of set. Row 3, 5, column 7, 9. Wait, what? I don't get that. You deleted it. All right. So I'm gonna highlight this because I think this is probably the key. I just have to find something here. They all have open ones. They all need ones. I mean, I guess that's a jellyfish. No, it's not a jellyfish on ones, but I guess there could be a 1 here. I don't think that would break anything. Let's see. Does there need to be a 1 here? No, it's a finned jellyfish on ones, right? These can't be 1. Does that do anything though? In fact, this is going to be a finned fish on 1, 6, and 7. And then, well, 6 is used a lot. Of 1, 6, and 7, is anything else? No, because these don't have anything in common except the 1. So yeah, we have a finned jellyfish on ones. Those can't be 1. So should I just fill what they can be? Can't be 1, so they have to be from 6, 7, 8, 9, but they can't be 7 either. This can't be 6. That can't be 9. Right. This is because no, this is a fin, so it must be 6, right? That's what we learned from Philip. That's what I got out of the video, at least. What are we? 6, 8, 9 triple. Where? Oh wait, hold on. This uses a 6 as well. Let me redo this one. Because it can't be 1, can't be 2, 3, 4, 5, 6, 7, or 9. This is a naked 8, and then that's a naked 9. These can't be 8 or 9. This is a 2, 8. No, it's not a 2, 8 hidden. 8 can be here. Almost made that mistake. Is this? Maybe there's more to be found with this, because one, 6, 7. Okay. So that's 8 and that's 9. 8 in this column must be here. So that's 4. What do I need here? I need a 1, 5, and 7. That places the 5. The 1, 7, 1, 7 pair, so this is 2 and something. 2 and 5. So this goes this way. Up. I meant to say that. This is a pair. No, it's not a pair. It's 1, 1, 3, 7. That's not 7. Do we get all the 9s now? That's what someone said. Nine's not here or here. Okay, this is not 9. So we get 1, 2, 4. That gets to 9 there. There's a 9 with the 6, so that's a 6, 9. Nice. And this is 1, 2, 5. Oh, there's a 9 right there. So this is 6, that's 9. So 1, 3. That's not 3 anymore, so this is from 1, 6, 5. It's not 1. I think this is probably just collapsing at this point. I'm just slow. 1, 3, 4, 7 in row 8, call me. So I've got a 1, 2, 5. This is another triple. So this should be a single at least. We've got 1, 2. We need 3, 4. We've got 5, 6. We need 7. So this is 3, 4, 7. This isn't 3. This isn't 7. But the 3, 4, 7 means this. What's missing? 6. Yeah. And then this is 3, 4, and 7. You guys making fun of me? Right to my face. All right. That's an 8 for the row. Yeah, I should have it from here. Just be patient, please. 2, 4, and what am I missing? 5. That's not 5. That's not 2. That's not 3. We have a 6 here. So that's 5, 4, 9. Stormtrooper scanning to the extreme on this one. This is why I never finish the gas puzzles on time. It's not 3. One, 2, 3, 4, 5, 6. That's not 5. So 5 in the box goes here. Okay, I can't do anything with 5s. What am I missing? Something obvious, I'm sure. 1, 6, 7. So this is from 1, 7. So that makes 1, 7, 4 pair. So that's 4. Getting ahead of myself when trying to talk. I'm gonna get rid of this coloring. That's not 1. 1, 6 pair actually I had. This isn't 3, obviously. So this is 3 or 5. Threes. Unfortunately, this can be 3. Oh, we have a 9 there. So that's 1, 3, 6, 2, 6, 1, 6. One, 2, 3, 6. Oh, there's a 2 in the row, so that's 1, 7, 3, and 4. 2, 7. We have 1, 7 pairs. So that's 5, 3, 5, 1. Just a bunch of 1, 7s left. Here, that's 3, 1, 7, 1, 7, 1, 7, 1. Yay, okay. So it was just a very well telegraphed finned jellyfish right here, and it ended up being the fin was 1, not 6. So there must be some kind of error in the construction, but good morning, Jessica. Jessica, if you missed my first puzzle, highly recommend going back and watching that. So good. No, I did not. I didn't do yours. All right, Michael, have a good lunch. Yeah, Davis, it's awesome. In fact, let's check up on it in the archive here. I want to rate it. It's probably small on the stream, but I call it out a 3. I agree. Very good puzzle. Interesting logic. We got 17 mind blowns just from people looking at this one. It's doing very well. That's great. I hope CTC is getting spammed with emails about it. They'll be forced to do it today. All right. What is next? Zatamath's not here. He does love to watch when I do his puzzles, so I know that he'll show up at some point. So I'll skip that one and wait for him to show up. So we'll do Kane's next, because Kane is here. Just a pile of arrows. All right. I would have called this pile of arrows. Okay. So this is called number. Maybe hashtag. Let's call it hashtag by Kane Puzzles. I'm sure he'll love that. The title is whatever you want it to be. It's number. I'm gonna go with number sign dash tag. Hashtag Kane Puzzles. Sharp in music, true. So we have standard Sudoku rules. We also have arrow rules. So the digits on an arrow sum to the digit in the bulb. So if this were 3 and 5, I have to put an 8 here because 3 plus 5 is 8. And that's it. I called it a bulb, but it's a circle. All right. Do we have any 3-cell arrows? We have a 1-cell arrow. So that might be important. I'll highlight it. 3-cell arrow. So 3 cells can be minimum 1, 2, 3. So 1 plus 2 plus 3 adds to 6. So this is from 6, 7, 8, or 9. So here's another trick. I don't know how helpful this is, but the minimum in these are 1, 2, 3, 4, which adds to 10, which means that this can't be lower than 5. You can sort of think of it as 5 is the first number that has 2 ways to add to it. You could do like 1, 4, and 2, 3, for example. So there's 2 ways to think about that. So this row has a bunch of arrows on it. Not that one. So we got 6 cells. So 1 through 6 adds to 21. And we have 3 arrows adding to 21, which means what's our minimum? We could have 2 9s adding to 18. These two can't be the same though. So these two are at least 5, just from our last logic, but with this one in the mix, yeah, so it's definitely more limiting, because if you think about it, if we made these 5, these can't be 5, because wait, what am I talking about? We can't have these add to. We can't have these be 1, 2, 3, 4. What I'm trying to say is we can't have these be 1, 2, 3, 4, because that leaves 5, 6 for here, and we can't put. We can try to put 11 here, but it's not gonna work. But 21. Let's think about it. If these were 2 9s, that's 18. So I mean, this could be 3, which is already its minimum. But let me think about this 21 a bit more. We have another one down here, so it's worth. The one down here is they all see each other, so I can't use the 3. I could do 4, 8, 9 though to add to 21. Okay, well, you also can consider that these kind of line up. 9 can't go in them. Or 9 can, this is, sorry, other way around. 9 can only, for these rows, 9 can only go in those cells. Now the question is, can these be 9? If this were 9, then these would be 9s. But I'm wondering if omitting 9 from this bulb is bad. I don't see why it would be. We wouldn't be able to repeat the 9 in that case. Is there a set going on? It's always possible there's some kind of set going on, but let's see. Is there another column where 9s are restricted? Because they can be on bulbs. Or a row, I mean. Hey, Telcat, welcome. Hey, it's Codec, right? Trying to map YouTube names to Discord names in my head, and I'm very poor at that. Okay, so the break in here is not easy. We've got these have to be 5 or higher, right? No, they don't. It's not a shared bulb, but these add to 10 minimum. So these add to 10 minimum. But they could still be like 1.9. Same here, these add to 10 minimum. No. Can't even say that. Is it? I feel like that there has to be something to the 9 restriction here, but I don't see what to do with it. Row 7? And row 7 is mostly bulbs. Two, 5, and 7. Hey, Sick, how's it going? Okay, so that's something to think about. If there was no 9 in these bulbs, remember these add to minimum 21. They'd have to be 21. And then this would have to be 6, 7, 8. Good weather for Sudoku? Always. Wait. Did I thought 4 was minimum though. 6 21. Yeah, so if we use a 9, we only need another 12. We could do 4, 8. But without the 9, 6, 7, 8 is the only way. Yeah, let's do that. I'll clear all my coloring out. We can start here. We know that adds to 90, and we can just do our arrow replacement trick that we always do. So that still adds to 90. Wonder if transposing this does anything. Okay, so let's pull up a calculator here. This is maximum 98765, which Simon has that memorized, but I don't. That's 35. Plus 9876 is 65. Plus 9. 9 plus 8. So 91 So we have 1 degree of freedom on the maximums. So this is 9 or 8. This is 7, 8, 9, and it has to have a 9 in it. So that's not 9, interestingly. This is 5, 6, 7, 8, 9, and only the 5 and 6 are in play. That actually makes it quintuple there. Oh, so then it can't have a... Am I thinking about that right? These have to have 7, 8, and 9 in them. So this is the 6. This is 1, 2, 3. That's our 1 degree of freedom. And so then this is 5, 6, 7, 8, 9. Very cool. So then these aren't 7. I can get rid of these highlighting. This is 5, 5, 7, 8, 9. Title refers to the shape? Okay. This isn't 8. Let's just good lift some more, shall we? It's not 8, 9. Check the total of the blue cells again. Pretty sure it's 80. Did I miss anything there? This one here. Oh, right, this one has to be 9. 8 plus 9 plus 9 plus 5 plus 7 plus 8 plus 9 plus 5 plus 6 plus 7 plus 8 plus 9 is 90. There you go. So these are not 9. There's a 9 in one of these two. One, two, three, triple, sorry. What is my scanning today? It is non-existent. This has to be 4, 5, 9. This is 6, 7, 8. Five, 7, 8, 9, but that one's a 9. Nine has to go here in the box. That's just from these 9s looking over. That can't be 9. You can't put 9 on an arrow. This can't be 4, so it can't be 4. So 4 is... Can this be 1, 2, 3? I think it could be. This would be 3, 4. It's not 9. Ah, that arrow adds to 9 because we got 9s here, no 9 on the arrow. These 9s look over. There's a 9 right there. We're going to finish the 9s. Maybe not. We have this 8-9 pair. We have these 9s. We have these 9s. 4-5 pair means these aren't 5, so that makes a 7-8 pair. So we need 1, 2, 3, 4 here. Not 4. What am I missing then? 6. 1, 2, 3, 6. There's a 6 in one of these 3. Right, this is a 5. It's the only place for 5 in the box. So these are 7s. These are not 7. That's not 7. That's not 7. If 7 were on here, this would be an 8 or 9. 7's up here somewhere. These aren't 5, so that's an 8-9 pair. This can't be 6 because there's a 5 on the circle, so that is 6. Which means this is 7 or 8, so this is 1 or 2. It's not, wait, did I misread my marks, I think? 6 can still be here. Hey Philip, very fun puzzle. What am I doing here? This is 1, 2, or 3. So this is 4, 3, or 2. What do we need? We need a 5. So 5 goes in one of these two. We do have an 8-9 pair in this row. So I'm wondering about 8-9 in this row. We can go here. There's the other of 8-9 is in here somewhere. You're not awake enough to follow these arrows. Maybe I'm not either, to be honest. I'm trying though. What do we have? Do we have any hints in chat for me? Let's see. I noticed this 5, 6, 7 here. So these add to maximum 14. So the 8's gonna go one of these two. And the 7 as well. Well, the 7's gonna go one of these two. What I meant is the 7 can't go on the arrows. If 1 were not on the arrows, we'd have 2, 3, 4, 5. Which is 14. So that's possible. But we need at least a 1 or a 2 on the arrows. Row 6, 8, and 9. Aha, this arrow can't have 8 or 9 on it. Because that's max 8. So we have a hidden 8, 9 in this row. We have 7, 8, 9 used. The one in box 4 is restricted. Is it? We can't do 1-8 on the 9. We can't do 1-7 or 1-8 on this 8-9. So the one is in one of these two. You can't put a 1 on the arrows here. I didn't see that. You put 2? Can't do 2-7 here. You could do 2-6 to make 8. Okay, so that's not 1. That does force there to be a 1 on one of these arrows. Oh, this is not 5. All right, this did end up being 7, 8, 9. So these do add to 21. So this is a 7 then, right? Okay. Do we know similarly what these add to? We almost know what these add to. These add to either 17 plus 5 is 22. So we add to either 22 or 23, which means these add to either 22 or 23. So these add to either 22 or 23. Oh, and we have a 7 on this arrow. So this is an 8-9 pair. So this adds to 17. So if I want to get to 22 from 17, I need a 5. So I need a 5 or 6. So this can't be 7. Oh, there's a 7 in the column. So basically I just learned what I just learned. What I could have just gotten from basic Sudoku. All right. That's good. Very good, David. All right, let's see. So this 5, 6 just directly determines this 5, 6 through the arrows or just through Sudoku. So this is an 8. That's 7. Let's just try to do some Sudoku maybe. Someone was saying this is... This is minimum 3. Can it actually be 3? If this were 3... No. We only get 2 more of 1, 2, 3, 4. So this has to add to 5 or higher. And so the only thing it can be is 6. So this is 1, 5, or 2, 4. But not that way. This adds to 5. I think I did that already. Got more 1, 2, 3, 4s here. So this is a low. Okay, so where's 8 go? 8 goes here. There's an 8 somewhere over here, but not here. So 8, one of these two. These are from 1, 2, 3, and 6. So that's one of these arrows has a 6 on it. Wait, what happened to 5? 1, 2, 3, 5, 6? Is that true? Yeah. So where's 7 go? 7's one of these two? Ah, 5's limited to beyond the arrow, so this is 2. This is 1, 5. Thank you. What is row 4, column 6? That is nowhere near where I'm looking, but okay. Can't be 5 because its arrow sums to 5, or row 4, column 7 is 5. Okay, yeah, an easier way to see that is if this is 5, this must be 1, 5, 6, but then that makes this also a 5. So this can't be 5, so the 5 goes here. So this is from 1, 2, 3, 4. 4 is one of these two. Whatever that's worth. If this were 4, that would be 1. If this were 4, that would be 1 or 2. Oh, this is 5 or 6, so this can't be 6. So that's clean. That makes that a 6. True. These arrow cells add to 10, that's a 5, so this is a 5. That's a 6. Why am I not seeing these things? I'm just kind of staring and not getting nothing out of it. So now that we want this to be 5, this can't be 1. This can't be 4. That leaves 1 in one of these two, so that's not 1. So we got 1, 4, and we've got 2, 3, 6 in this box. Ah, yeah, because we have this 6 as well. So this is 6. This is 3, 6 to add to 9. This can't be the 2, 3. This is 1, 4. This is going to be 2, 3. And can this not be 2? Or did I remove? I removed the wrong thing. All right, so that's a 2, 3 pair. E6. So this is hopefully adds to 7. Yeah, 2, 5. We know the order because of the 1, 5 pair. This is 1, 2, 7 because 7's on the arrow, and this is 8 or 9. And the 2, 3 pair actually tells us what it is. Oops. 1, 7 makes 8. That's 9. That's 8, 9, 8, 9. This is 4, 5, adding to 9. This is 1, 2, interestingly. And this is 3, 4. Is the 5 resolved? I don't see how the 5 is resolved. Maybe that was an earlier message. All right. Row 2, column 1. Ah. Just get rid of it. Eight in this column's limited to these two. I think it can be on the arrow, 8-1. Ah, this 1-5 pair does give 7 and 1, and now this can't be 8-1, so that's an 8. That's an 8. That's an 8, unsurprisingly. We need a 1. No, we don't need a 1. What is it? 1, 2, 3, 5. We need to definitely have a 6 on one of these arrows. This would either be 6-3 or 6-2. 6-3. Okay, how do we make this 9? So this can't be 1. It can't be 2 because that can't be 7. Could be 3, 6, 4, 5. Can't be 5, 4. 6, 3. 7, 2. Can't be 7, 2. Alright, so those are our options. Okay, 1 can't be on the 8 sum. It's either 3, 5 or 2, 6. What's wrong with 4, 5? Oh, the 1, 5 pair here. It is only 3, 6. Oh, and 1 can't be here because you can't do 1 plus 8 equals 9 because 8's used. So that leaves 1 in the row there. Let's see. This could be 2, 7, 3, can't be 3, 6, 5, 4, I think is okay, 6, 3. So this is 3, 5. This is a 2, and that's 6, 3. Oh, that doesn't work. If this is 3, 5, this is a 3, that leaves just 6 here. How do you add to 9? With another 3. So it's not 3, 5. It's 2, 6. That puts a 3 here, 5 here, 4 here, 7 here. It's not 5. These aren't 2 or 4. So this is 2, 1, 3. 2, 4, 3, 4, 6, 3. These aren't 2 or 3. What do we have left here? Oh, this isn't a pair though. We need 1, 2, 3, and we need 6 and 7. That's not 6. I don't think 7 can go on the arrow. So that's a 1, 2, 3 triple. So we have a 6, 7 pair here. Do I want to look at what this can be? There might be more Sudoku first. Ah, yeah, like this is a 7. This is 6 and 8. So that, yeah, that simplifies things. That's a 7. 6. So blindly, we need 1, 2, 3, 4, 5. Let's see if any of that cleans up. These can't be 5. So this can't be 1, 6. It can't be 2, 5. It has to be 3, 4. This has to be 2, 5. Leaving a 1 for here. This is 4 and 5. 1 and 4. 3, 2, 1. 5, 4. These 2s line up. Probably an easier way to do that, but let's do it this way. 2 and 3. 2 and 7, looks like. 2 and 5. 6 and 2. 3 and 6. 3 and 1. There we go. We did it. Was there an easier way to see this logic of this couldn't be 3, 5? I thought that was pretty neat, but felt like I was overthinking it. Yeah, nice puzzle can as always. There was an easier way? Yeah, okay. Could have first deduced the 7. Okay. Okay. Lots of ways to think about things. Very colorful. All right, this is called Cindy and the Lost Numbers with Lost capitalized. This is by Wario. Ah, this is your puzzle for the dedication June puzzle prompt. That's cool. So we got normal Sudoku rolls. We've got standard thermos, arrows, palindromes, and little killers. So I guess this is an arrow. So these 3 sum to this circle. These are thermos. So digits increase from the bulb end. They don't have to be consecutive though. So you could do like 2, 5, 7, and 9. Oh, that's going to be hard to read. These are palindromes. Guessing the pink is also a palindrome. So the digits, it reads the same forward and backwards. So these 2 are the same digit, these 2 are the same digit, these 2 are the same, and these 2 are the same. That's a thermo, I believe. Hopefully they're visually distinct enough. So we have just the 1 arrow. We have these thermos, 4 thermos, and then we have 2 palindromes. And then we also have killer cages. And digits within a cage can't repeat. So if I put a 5 here, I can't put a 5 here, even though normal Sudoku rules allow it because they're all in the same cage. And they must sum to one of the numbers 4, 8, 15, 16, 23, or 42, which are the numbers from Lost that kept showing up over and over again. It doesn't specify that there's one of each. I wouldn't be surprised if it's one of, let's see, 1, 2, 3, 4, 5. Well, there's 6 numbers and 8 cages, so there must be repeats, right? Yeah. So there's going to be repeats. Okay, so let's get started. 1, 2, 3, 4, 5, 6. Yeah, so 7 digits minimum are 1 through 7, which adds to 28. So this has to be a 42 sum, which means the remaining in the box is 3. So that's a 1, 2. Because 45 minus 42 is 3. Using the secret. 1, 2, 3, 4, 5, 6, 7, 8. This has 8 cells, so it's just missing a 3. So it has everything except a 3 in it. These 3 go somewhere here. So these 2 go here somewhere. Let's look at this cell in particular. There's probably an easier thing to look at, but I think it's interesting. This cell can't repeat in the cage, can't go here, and it can't go here because of the palindrome. So that cell is in one of these 2. I just found that interesting. This one goes in one of these 2. Oh, this one is actually... This one's actually here. Maybe not orange. Maybe purple. This cell is exactly here, because it can't repeat in the cage. It doesn't go here, and it can't repeat on... It can't be on the palindrome here. Which means... Yeah, we don't know as much about this one. This one is it. This one could be on the palindrome. This arrow is in a cage, so it can't repeat. So this is at least 6. Oh, this cage. 1, 2, 3, 4, 5, 6, 7, 8. Oh, this is another 8 cage. So this cage is missing a 3, and this cage is missing a 3. So the 3 goes here and is repeated on the palindrome. Thanks, Jessica. How many cells is this one? 1, 2, 3, 4, 5, 6 cells. 6 cells could be a 23. And actually, it can't be a 42, because we can't be missing 3 in 3 cells. So, this adds to 23, which means these 3 add to math. 22. 22 and 3. 987 is 24. So where does 3 go in? We know purple's not 3, so 3's in one of these 2. And it's the one that's not red. So this one actually does repeat on the palindrome. These are all the same. Make that gray. I'm wondering if I can hide colors. So just to say, where does gray go in this box? It can't go in this cage. It's not purple. This is a red 3 hidden. So it has to go here. There's no rule that says all of the cage totals are present. So I can't just say this is a 4 cage. This could be 4, 8, or 15. But that does mean that limits what this number can be. Yeah, Wario said it too. So, but it is 4, 8, or 15, or 16. Could be so many of them. But yeah, so this is 20. So these add to 20. These add to 22. So if this can't be 4, these need to add to, let's see, 22 minus 9 is 13. These need to add to at least 13. So this is 15 or 16. So 16 would have to be 9-7. 15 can be 9-6 or 8-7. Which means to get to 22 from 15, we need 7. So this is 7 or 8, which is repeated here. Can we... If this is 7, 22 minus 7 is 15. We would have to do 6, 9 to make 15 because 7's used. If this is 8, then these add to... Wait, 7 is 16. What am I talking about? 22. Did I even pick the right numbers? I'm going to use my calculator because I feel like I'm just screwing this up. 22 minus 15 is 7. So if this were 7... Wait, is this even where the palindrome repeats? Am I just... The palindrome repeats here. If this were 7... Making all sorts of mistakes. If this were 7, this adds to 15, and it can't use a 7. So that has to be 6, 9. Okay. If the cage is a 16, it's a 6. So yes, I did screw that up. And if this is a 6 and this has to add to, well, to get to 16, it has to be 9, 7. So there is a 9 in this cage. And I'm sorry about all those mistakes. Yeah, these numbers are, it's reference to Lost here. The show. Let's see. So 9 isn't one of these two. Nine actually, gray and red can't be 9, and 3 can't be 9. So 9 doesn't go here. It's because red and gray are on a Thermo. Purple could be 9. It's not. That's not limited enough. There's a little killer. I didn't even explain the little killer rules. These two add to 4, and these 3 add to 8. I just didn't even notice the little killers. So this is 1, 3. This has to have a 1 on it, so the thermal bulb is a 1. And this is either going to be 2, 5, or 3, 4. These add to 7. The blue on blue is so hard to read. Alright, let's think about these cage totals some more. This cage could still be a 23 cage. Yeah, where I always use the CTC software. Okay, there's a 3 in one of these two. And it can't repeat on the palindrome there. So this is 3, 1, and 3. Oh, the 1 actually already did that. So this is 2, 5. This limits 1 on this arrow. But the arrow doesn't have to have a 1. It could be 2, 3, 4, 9. Can it be 2, 3, 4, 9? The 3 would be here. And then we'd have 2, 4. So that would be 9. And then, well, of course it would add to 9. And then, okay, let's look at our possible cage sums for a 4, cage. We'd be 15, 16, or 23. So, but we know these three add to at most 9. We could add to 6 if this were a 9. How big can we reach with a 9? 9, 18. So it's not a 23. It's 15 or 16. Can't be 8. So this adds to 15 or 16. If this were a 6, this would have to be 9. So it'd be 1, 9, 2, 3. I don't know if that's the right thing to look at right now, maybe. Okay, let's look at 3s then, I guess. 3's up here. This cage doesn't have a 3 in it, right? Yeah, so the 3 can't go here or here or here. So there's a 3 in one of these two. If the 3 were here, then this arrow wouldn't have a 3 on it. So that immediately removes 6 as a possibility. It also would immediately place a 1 here, because we'd have to have a 1 on it. It's too much to think about for now. Wanted to look at this sum as well, but is there more easy? Oh, there's a 1 in this box goes here. Maybe there's just more Sudoku. Yeah, 1 goes here. This cage needs a 1. Could be in these 3 though. No, could be in one of these 2. How about this column? This column needs a 1. And this 1 eliminates 1 from all 3 of these. So the 1 goes here. So now we've really limited 1 in this box. It's in one of these 2. In this box, we need a 1 that... Oh, so wait. Purple can't be 1. Red can't be 1. 1... Wait. Did I just remove 1 from every possibility in box 5? Did I screw up my logic on this column then? Or replacing this one? Could the purple be wrong? Where does purple go in this box? It can't repeat in the cage. It can't be on the repeated palindrome. It can't go in these 2. The purple must go here. So this one's not actually 1. So how did I get this one? I looked at... Oh, because I thought this was a Thermo. So the 1 could actually repeat here. So one of these 2 is a 1. I think I just proved it's not here, but I don't want to do it that way. It's all the different meanings of the lines is what confused me. So now where does 1 go in this box? It could go here. So gray could be 1. We kind of know gray is 1. How do we prove it? So 1... Either way, 1's not going to be on these legs of these cells of the palindrome, because 1's in one of these 2. So that's eliminating it. And also we have the 1-2 pair. 1's not on the Thermo. So 1 is in one of these 2. Would it be problematic to be in the purple? Maybe? because it's in the purple. It would have to be here for the cage. That seems okay. Oh, the one in box 8 sees the purple. Okay, so this is one. I can get rid of my gray. So now that places the one here. And a one in one of these two. Sorry, I'm making a mess of this. Maybe the colors are screwing with me. 3 red, purple. Red can't be too high, can it? Guess it could be between 2 and 7. Can be pretty high. Okay, there were a couple of cages I wanted to think about if we're ready for that. We have 2 3-cell cages that have a 6 and a 7, 6 or 7 in them. And then this is either this can't exceed 7 because it's either 3 or it's a red, and red can't exceed 7. If red were 7, this would be 8, 9, which would mean purple is less than 7. So the best we can do if this were 7 would be 6 plus 7 plus 5. So 5, 6, 7 is 21. So what if this were not 7 instead? What if this were... This would have to be pretty low in order for this to be high. Like, let's see. If we want this to be 9, we have to go 8, 7, 5. Because we can't do 6 anymore if this is 7. And that would make this a 6. Why is it a 3? I limited 3 to these 2 cells. Box 4. How is it? Oh, I see. These 3s look down. Okay, so that's a 3, that's a 3. This is red. So these add to 10 maximum. So this is 6 maximum. Minimum? No, okay, we can't be 8, so we're 15 or 16. If these are 8 and we're 15 or 16, then we would be 7 or 8. These add to 9, or sorry, wait, what am I doing? 6 plus 3 is 9. So if this is 6, 3, 9, or this is 6 plus 3 equal to 9, then we need a 6 or a 7 here. If this were 7 plus 3 adding to 10, then this would be a 5 or 6 here. Wait, but then 6, 3, 9, we can't repeat the 6, right? We'd have to be 16 with a 7. Let's try that again. So if this is 6, 3, this has to be 7. If this is 7, 3, this could be 5 or 6. Okay, so it's still the same options. And that's cloned there. Not sure how much that helped, but we also have the same kind of thing going on here, but we don't have a 3 placed in here, so it's harder. We do have kind of a limit on what these can be. In fact, let's look at this one. Make that green. That can't be 3. So it's either 5 or whatever's here. Can't be 9. Yeah, that doesn't really help. And then this one, make that blue. Goes down here. But it can't be 1, so blue is one of these two. So blue can't be 1, 2, 3, or 5. Or 9. So if it's not 1, 2, 3, it could be 4, can't be 5, could be 6, 7, or 8. Oh, I do have this 6, 7, 9 triple, so that's not 6 or 7 either. Two in box 2. We don't know anything about 2s. You're gonna have to explain 2 in box 2 to me. Okay, if purple were a 5... Ah, that's good. That's a good point. If purple were a 5... So purple is one of these 3, I guess is the way to put that. And none of these can be 5. So these are from 6, 7. All these 6, 7 pairs. Does that limit this Thermo? This could be 9, 8. So this can't exceed 5. Because even if this were 9, 8, 6 and 7 are used. So this would be 5 max, and it can't. So it could be 2, 4, or 5. Anything see that? Oh, but we just said red has to go here. So this one's red, because it can't be 6, 7, or 9. So this is a 2, 4, or 5, and it can't be 5, so it's not 5. Where does 2 go in this box? Could be this one, but otherwise can't be the green, because the green sees the 2 here. So 2's in one of these 2. Almost good. Just looking for stuff to do. 2 in box 5. These can't be 2. Ah, the 2 does see the... There we go. The 2 sees the palindrome. So 2 can't be here. And these can't be 2 because of the thermo. So that means 2 is in one of these 2. That points down at the only other place for 2, so that actually just makes red a 2. So we can remove that coloring. I could give this other 6-7 a color. How about yellow? So that's not a 2. So that gives us 1 and 2 here. It gives a 1 on the arrow, which is where I suspected it would be. This can't be 1, 2, or 3, so this is at least 4. So that eliminates 6 from here. So this is 4, 5, or 6. Does that mean this is always a 2? Can it be a 3? Could be a 3. Could it be a 4? No. So this is 2 or 3. Purple in box 6. Ah, that's cool, yeah. So purple is 6 or 7, so it's not these givens. It's not on the palindrome, and it's not in this row, so purple's here and it's a 6 or 7. Should we look at yellows? Yellow's on the palindrome somewhere. It's one of these 2 and one of these 2. And then we keep going with purples. Purple's in one of these 2. That be narrowed down. Not that I can see. So yellow in this box is one of these 2. Right, okay. This 8 cage needs a 2, because we know it's only missing the 3. So where's the 2 gonna go? Because we have a 2 in the box now. So 2 is in one of these 2, which eliminates 2 from here. So this has to be a 3. That's a really good spot. Thanks, Carl. So with this being a 3, that means this can't be 7 anymore. And this can't be 6. So we're either 1, 3, 4 or 1, 3, 5, adding to 8 or 9. Yellow is almost limited in this box. What about yellow in this row? Can this be a 6 or 7? I guess this could be yellow because this is... Wait, is this a palindrome? This is a palindrome, okay. What are we seeing? Back to row 8, column 3. They're the green. Min is 4, but can't be 4. Are we looking at the cage or... So the minimum these would add to is 10. 4 plus 6. It's hard to think about this. Oh. Okay, so 4, 5. We have 6, 7, we need 8. So 4, 5, 8 is what's left for this box. This is 4, 5, or 8. One of these is a 5. If this were 4 or 8, that would go here. Okay, so if this were a 4 or 8, that would add to 12. So our sum would be either 18 or 19, neither of which are valid sums. So this has to be a 5. So green ended up being the 5. So with this being a 5, we could be 6, 4, 5 to add to 15. We could be 7, 4, 5 to add to 16. What about an 8? 8 plus 5 is 13. Plus 6, so yeah, 13 doesn't work because, yeah, we'd be 19 or 20. So this has to be 4, so that gives blue as well. Get rid of that color. Wario, constructors are only supposed to help when I ask. You're giving a lot of hints when I'm not even stuck, so appreciate it if you be patient with me. You did this last time too. I mean, I can mute you. You have to follow the rules of the channel. Or, I mean, you're not excluded from following the rules. And following rules shouldn't be that hard. If you prefer me to do showcases in video form, I can do that, but I don't do showcases that often anymore. And they have to be exceptional puzzles. Purple in the big cage. The big cage. You mean this one? Because there's 3 cages that are of equal size. 2 cages of equal size. Anyway. So, yeah, purple has to be in this 8 cage. Ah, they can only go in one place in this cage. So they can't repeat in the box, and then this purple stays here. So purple is here, and we know purple has to be in this cage. So that gives us this purple. Purple's down here. Oh, for the row? True, I think it's hidden in the row, so can't be here. Can't be in any of these, it can't be here. Okay. So for the row, it's here. So that's a 6, 7. Let me see if I can finish off these purple. I don't think they'll finish, but let's see. No. Maybe up here? Purple's one of these two. Guess not. Where does row 2, column 7 lie in box 2? Row 2, column 7 is on the Thermo ball. Where does it lie in box 2? It has to be one of the 2 or the 3, I guess. Can't repeat in this cage or in the row, and it can't be 6 or 7 because we have a purple up here already. It sees a purple. So this is 2 or 3. Oh, and it sees a 3 as well. So this is 2. It puts a 2 up here. That Puts a 2 down here and here. And we just finished the 2s. Awesome. 3 now is here, which means that purple is here. It's a 6 or 7. So purple's one of these 2. And purple's one of these 2. Might as well mark that. So 3s are done. 2s are done. How about 1s? 1s are also done. 4s are very much not done. I don't know a whole lot about 4s. This column's pretty limited now. We have 1, 2, 3. We need 4. We have 5, 6, 7. We need 4, 8, 9. So this one's not 4 and this one's not 9. Do I have anything else seeing that stuff though? Nine in this box is one of these 2. Almost useful. True, I do have some other open columns. So we have 1, 2, 3, 4, 5, 6, 7. So these are 8, 9. That makes an 8, 9 pair here. And row 7. True, okay. 1, 2, 3. We have 1, 2, 3, 4, 5, 6, 7. These are 8, 9. So that Thermo is not incredibly helpful. At least maybe it already did its job. These are from 6, 7, 8, 9. Yeah, minor deductions. Let's see. Is this Thermo doing anything interesting? What about this repeated digit? If this were yellow, that would put yellow here and here and here. That all seems likely. It's already here somewhere. So it would be here and here and here. I feel like Mark. All right, yeah, that all works. So that's one option for the yellows. The other option is here, here. I don't think this propagates anywhere. It's not here anymore. I don't know. Yellow in box 7? It's in one of these 2. This is 15 or 16. This is 16. Are any of these cages... Okay, well, how about this? If this added to 8, we'd have to be 8, 7 to make 15. This added to 9. We could be 9, 6, 15 or 9, 7, 16. Okay, so that all works. Darn. Any other cages that are... The other cages are basically done. Yellow in column 1. That's a good question. Oh, there we go. Yellow goes here. That should help. Because I think that means... Nope, yellow's still in one of 2 places here. We already knew yellow was one of these 2, so But it's nice to have that. This is an 8-9. Should I color the 8-9s? That might help. Why not? How about green and orange? That's not a good place to start. Right, this is orange. So this one's orange, this is green. So green in one of these two. This one's green. You just got row 4, column 3 equals row 5, column 4, and nothing special happens? I see. This one's not orange, and this one's not orange, so this one's orange. That puts an orange down here somewhere. Don't know if I want to mark that or not. Does this tell us anything? Green in this row. Okay, green is one of these two. Nine in row 3 is forced. Can this not? This can't. Yellow can't be 9. Yellow's a 6 or 7. Okay. But we don't know this is yellow. If this were 9, that would be 9. That would be 9. That would make green 9. I don't see it. Orange in row 3. Okay, so that's not orange. That's not orange. These aren't orange. Ah, this palindrome can't be orange, so that helps. There we go. So this is orange, and it can't be 9. Let me just double check that. This can't be orange because this orange sees it. This can't be orange because it's not 8 or 9. It can't be orange, and then there's an orange already in this box. Okay, so orange is 8. This is 9, and it's the green. I'll probably clean up the colors in a second, though. So these are 9. These are 8. That puts 4 and 9 here. And there's a 9 in one of these two. Oops. There's a 9 in one of these 3. It's not here or here, so that's 9. Right, that's 9. Sorry, there was an 8 in one of these two. That goes here. I'm going to clean up these colors. Greens, clean up. That places this 9. Do I have all the 9s? This 9's placed. This 9's placed. That's nice, because now we know where purple is. Purple's here. Which means this one's not purple. So this is purple and not a 4. So that places this 4. This is purple. It's a 6 or 7. I don't know what happened here, but I'll put that back. And then this is 8, so now we know this is 4. And these added to 8, so we have to put a 7 here for 8, 7 to add to 15. So now we know purple is 7. And then, so therefore yellow, which we don't know a lot about yellows, but these yellows are 6. And I can corner mark 6s here and get rid of that color as well. This is a pair. We have 1, 2, 3, 4, 5. We need 6 and 8. So we actually know the order. In this row, we have 1, 2, 3, 4. We need 5 and 6. And I might be blind, but I'm not seeing that being resolved. 1, 2, 3, 4, 5. Okay, so that's 5, that's 4. This is 4. Is this also a 5, 6? Yeah, so this 5, 6 deadly pattern is going to get fixed by this duplication here. Is there something keeping this from being 5, 6? Yeah, that's going to have to propagate from up here. What do we have here? 1, 2, 3, we need 4, 5, and 6. So that's not 4, that's not 5. This 6, he's here, so that's 5. These are 6s, that's 5s and 6s. That's 5 and 6, that's a 6. We need a 4. We need a 5. And 8. Sweet. Hopefully I got that right. Looks right to me. Oh, who did Philip? Was it Simon? I'm gonna have to watch that after the stream's over. Nice. I predicted it. Simon does it. All right. Too bad I can't watch that right now. You guys are gonna wait till after the stream, right? Okay. Let's move on to the next puzzle. Thank you, Wario. That was a nice puzzle. Yeah, you just gotta work on the back seating a little bit. I get there. And I will ask for help if I get stuck. I'm not beyond asking for help. I just prefer to not get the help until I ask from someone who's already solved the puzzle or a constructor. Yeah, the hazards of my stream overlapping CTC. He loaded it live. Oh, I'm getting like a play-by-play here. All right. All right. This might be a new constructor. It's very hard to search PMs, but I would like to contact him to let him know I'm about to solve the puzzle. Is Simon gushing over it? There we go. Marcel. All right, I pinged him, so hopefully he'll join us. He did specifically ask for Saturday, so hopefully he can join us. All right, well, let's do this puzzle. I'm excited about Simon's reaction to that. You guys have to put up with me for another 90 minutes, and then you can watch Simon's video. All right. Links, of course. Worm's always got my back, reminding me every single time to do this. Jessica, did you watch my solve yet of it, or? Wasn't sure if you went back and did that. You sped through it? Nice. All right, so we've got, this is Urban Planning by Dr. Ecke. Digits in cages don't, we got normal Sudoku rules, digits in cages don't repeat, and sum to the indicated total. So these are normal killer cages. So The non-repeat rule does not appear to actually apply to this puzzle, but these three would sum to 23, and these three would sum to 9, for example. All digits act as skyscrapers, so what does that mean? Digits that appear in squares are also skyscraper clues and indicate the maximum number of skyscrapers visible in any of the 4 orthogonal directions. At least one direction has the exact number of skyscrapers visible as indicated by the digit in the square. Okay, so let's go over that. So skyscrapers are normally clues on the outside of the grid, but let's do it in reference to one of these squares. Let's pick a corner because there's fewer options there. So let's say I put a 5 here. What that would mean is in one of these two directions, let's just say it's in the row, I would be able to see 5 skyscrapers. Now we can sort of imagine a number as a building of that height. So if you're looking from the 5 in this direction here, what buildings could you actually see? Well, so like let's say I put a 2 here. Well, this would be building a 2-story building. So I would be able to see any building behind it other than a 1-story building. So if I put a 1 here, I ignore the cage obviously. If I put a 1 here, that's not visible. But now, whatever I put here, say a 3, that's going to be visible because I can't do anything lower than a 2. So we now have 2 visible buildings here. And then I could do, say, 7, 8, 4, 6, 9. And if we look, as we look this way, 3 is the highest building I've seen, so I can't see anything lower than 3. Now I have a 7 here. So now I can see the 7, but now the 4 and the 6 aren't visible. But I can see the 8 and the 9. So now I've got 5 visible skyscrapers in this direction. So yeah, the all digits act as skyscrapers means that the digits are buildings, right? The digits are the skyscrapers themselves. But then the digit in a square also indicates that in one direction, that's the exact number of skyscrapers seen. We also have another rule that it's also the maximum seen in any of the 4 orthogonal directions. So I can see 5 or fewer skyscrapers in this direction as well. I feel like this is going to be very hard. But hopefully this makes sense. Yeah, at least one direction must exactly fulfill the clue, and in all the other directions, we have to see that number or fewer skyscrapers. Yeah, it's not saying every digit is a skyscraper clue, it's every digit is a skyscraper. All right. Although 1s aren't very tall. Right, so we can make a few deductions immediately, which is that 9 can't be on a square, because there's no way to see 9 skyscrapers, not including itself. Let's do this. The 23 is 6, 8, 9. Any other obvious? This is a 6. Why do a given when you can do a 1-cell cage, right? None of these squares are 9. Okay, so this is not a 6. One, two, four, and okay, so 21 plus 17, we can use the secret. 21 plus 17 equals 38. And so in order to get to 45, we need to add 7 to that. And 7 in 3 cells is 1, 2, 4. I got there. There's a 6 in one of these two, so this 9 can't have a 6 in it. So it's from 1, 2, 3, 4, 5. Oops. For whatever that's worth. So, can a square have a 1? That's a good question. It certainly can, because like this square can have a 1. Because the one it can fulfill, we see a maximum of 1 in any direction. That might not be fulfillable. It would have to have a 9 next to it. So like, maybe this could be a 1. Could it? No. We'd see one skyscraper in all directions. There's no way. You could put a 1 next to it in one direction, but in all the other directions you'd have to have an 8 or lower. So you'd always see the 9 as well. Well, yeah, but then one of these is a 1, so which one can actually be a 1? How does that make sense? This one can do it, you're saying. Repeated 9s and 8s. Okay. Yeah, so if this is a 1, we could, for example, do 8, 9 like this and 9, 8 like this. And this will be fulfilled because in every direction we see one skyscraper because the 9 is from the other direction. So that's the only one that can do it here. So this is a 1. And then these are all 8, 9s. And I think they have, well, do they have to be 8 though? Because we can hide a bunch of digits to the left. No, I don't think they have to be 8. We just have to have a repeated 9. The only thing we have to do is repeat a 9 to fulfill the 1 clue. So none of these can be 1, because I can't repeat it, a 9. Wait, I can repeat a 9 like this, can't I? This can't be 1. Can't repeat a 9. This can't be 1. But this one on an edge, I could repeat a 9 here, so this could be 1. If I did that... Oh, no, I can't. Because of the 23 cage. If this were a 1, I'd have to repeat a 9 on both sides of it. And that would eliminate 9 from the 23 cage. So this is 2, 3, 4, 9. I don't know how to remember that 9's going to go in somewhere here, but... Yeah, one of the directions is exactly the correct, and all the other directions are either correct or fewer. So this clue is going to be really hard to fulfill. It's going to need some high digits early on. That's not the rule, Michael. It's one direction's exactly correct, and all the other directions are that number or fewer seen. Can't see more than the number on the square in any direction. Row 3, column 8. Okay. This cell has to be higher than this cell. That's all we know. Same here. So yeah, it kind of acts like a thermo. Well, this is kind of a backwards thermo. The one is not the bulb. This is higher than this. This is higher than this. So, so these can't even be 5, right? Because we can't put 4. Well, we could put a 3 in one direction, I guess. We could do 5, 3. The 6 can't see 6 to its left, you're saying? Right, so this is the largest building going this way. Because we can't have an 8 or a 9 here. So at best, this is the largest building. If we could have a 9 earlier, and then it's not seen at all. But so we could see 1, 2, 3, 4, 5 maximum. So the 6 is actually in this direction. It's unlikely this 2, 4 is seen. So 1, 2, 3, 4, 5. Can this be seen? If this were a 4, no, there's no way this 4 this cell's not seen. So all these cells are seen. So yeah, it's like a thermo. So 9, 8, 7, 6, 5, 4. I think this is from 1, 2, 3, 4. Let's start with this. This is from 1, 2, 3, 4, 2, 3, 4, 5, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. Now, is there any other limitation on this? Well, we can't use a 6. So that's not 5, that's not 4. So we could do 7, 5, 4, 3, 2, 1. Theoretically. Or we could do 3, 4, 5, 7, 8, 9. Okay. That all seems to check out. This places a 9 in row 3. Does it? Okay, well, this has to be lower than this. So this can't be a 9. So this is 3 or 5, 6, 7. And so this has to be the 9. True. We got a 9 in one of these two. I was thinking about it wrong, but yeah, it should have been obvious that this is now the 9. But now we still don't know where the 9 repeats. It's one of these two. Maybe I don't want to confuse myself. Wait, does that mean this one? If this weren't the 9, I guess this could be 8, and then the 9 could be up here, and that would be fine. Can't do 2, 3, 4 on the thermo, so where would we be in danger of doing that? If this were 4, this would be 3, 2, 1. And that's no good. So that's not 4, which means that's not 5, which means that's not 7. Row 6, column 8. Interesting observation. Let me think about that. It's guaranteed to see these 4, because the 6 is telling us that. So this is a 4, which actually just immediately gives us all of these. That gives us the 9 here. This is 2 and 4. So these are from 1, 3. The 17 cage. These add to 9. So we could be 3, 6. Can't do 5, 4. Can't do 7, 2. So yeah, that's a 3, 6. And then this, we actually know the order this has to go in. It has to 21. So, oh wait, we just look at what's left in the box. 1, 2, 3, 4. We need 5. Oops, the 5 goes here, and then we need 7. How do we do this 2 clue? We gotta have a 9 before the 8. So there's a 9 one of these two, and there's an 8 one of these two. If this were 9, 8, this would be a 1. And there's no way that this 1 clue is getting fulfilled. This square can't be a 1. And the reason I say that is this direction, I think. I can't put a 9 here. So it's going to see a 9 down here somewhere. So it'll see 2. So this can't be a 1. So if I were to put the 8 here, this would have to be the 9, right? Yeah. So the 8 goes here. And the 9's just somewhere before the 8. These 9s line up, putting a 9 in the 20 cage. Can never put a 9 on a square. Also, it sees this 9. What are we seeing? 4 clue and row 1, column 9? Ah, this 4 clue. So it doesn't see 4 to its left, so it does see 4 under it. Does that help? If this were a 6, we'd have to see 7, 8, 9 in order. That would go down here. I think that's still possible. We need another 9 in this box. Can't do 1, 8 or 2, 7 or 3, 6. So this is 9, 4, 5. That's not the 9. Ah, interesting observation. Yeah. If this were 6, 3, I just said this has to be 7, 8, 9. That's the only way to see, because 7 can't go here. So this has to be 7, 8, 9. Now we're seeing 4 in this direction. But what about this 6 now? How's it going to see 6 in this direction? Won't it see 6? 1, 2. It'll see 6. Oh. No, it's not the 6 that's the problem. It's this one that's the problem. This is going to see at least 3. And it can't be 4 or 5. In order to fill this 6, we'd need 2 of these to be... Wait, can this see 6? 1, 2, 3, 4. I'm confusing myself greatly here. This can't be 1 or 2, so the 1, 2 would go like this in order to fulfill... No. Yeah, okay, this doesn't work. I'm just gonna say this it really doesn't work for this clue here. Which would have to be greater than 3. And 4, 5, 6, 7, and 9 we're using. It can't be 8. Okay. Well, what? Well, can't this clue be fulfilled to the left? Oh no, it only sees 2 to the left. Okay, yeah. So this is 3, 6 this way. This only sees 3. So it has to see a 9 before the 7 or 8. Wait. This has to see 6. Oh no, it doesn't. It's not. It doesn't have a square. What am I talking about? Does this see 2? No. This has to see 2 to its left. It does. This sees 3 to its left. Okay, these are all fulfilled. Yeah, this is this sees 2, so it's 1 or 2. But I don't think it can be a 1. Because we can't put a 9 right under it. So this is a 2. Puts a 2 down here somewhere. Well, what's left in this box? We've got 1, 3, and 8. So, oh, and one more. 1, 2, 3, 4, 5, 6. Oops. But this is not 3 or 6. So this is a 1, 8 pair. This is a 3, 6 pair. So this triple is, let's see, 2, 4, and 8. And this triple is 1, not 1, 1, 2, 3, 4, 5, 7, and 9. Okay, just wanted to fill that. So this only sees 2. So if this were a 1, then it would see 3 by definition. So this is 8 and 1. And then we're good. Wherever the 9 is, we're good on the 2. And then we know that this is the last building. So the reason it couldn't be 6 is the same reason it can't be 8. It only sees 5 to up to 1, 2, 3, 4 to its left, actually. All right, this one. Wait, this one's a 6. Right, it fills the 6 upwards. Wait, can this? Right, this is maximum 4. 1, 2, 3, 4. How many does it see above it? Stops here. 1, 2, 3, 4. Okay, so we don't know how that works. But if this were an 8, it would have to see 4 in order here. All right, I'm kind of circling right now. Let's look somewhere else. This one here can't exceed 4. So let's start with that. Can't be a 1. And that's a 2, 3, 4 triple. True. 2 seems difficult. This would have to be 7. The 9 could be next to it here. So this would be 7, 9 if this were 2. What about up and down, though? We need a 9. Okay, if this were 2, this would be 7 and 9. We just need something higher than 4. I think this is doable. All right, well, I'm not going to look at that more. Row 2, column 4. Does look down. Can also be a 6, that's true. I think there's too many options for that. I think 2 is possible. So 2 and 3 can't go here or here. Can I limit it any more than that? Ugh, unfortunately not. This square. So we need 11 more in the 20 gauge. Let's see. This needs to... I'm trying to see why you're saying it's at least 4. Is it because of the cage, or... Well, let's see. It sees a 2. Can't be... Can it be a 1? No. Can't be a 1, because the 9 to its right is here. Can't be 2. Can it be 3? If it were a 3 with a 9, that has to 12. Oh, and we can't put an 8 in the cage. Okay, so it can't be 1 because of the 9 here. It can't be 2 because of the 2 here. Can't be 3 because that would be 3, 8, 9 to add to 20. Actually, 1 and 2 just don't work for the cage at all. Because 1 and 2 can't be used to make 11 without a 9. Can't be 3 because we can't make 11 without an 8. So this is 4, 5, or 6, I guess is what we're saying. Can't be 7, and we certainly can't see 8 to our right, so... Can't be 6. 1, 2, 3, 4, 5, 6. It could barely be 6. Six doesn't work. 6 with 9 would be 15. We need a 5. I'm confused. It's because of the 15 cage. Okay. Okay, if this were 6, we know these are strictly increasing. So what would be left? Because we know exactly what would be. If this were 6, we'd need a 1, 3, 4, 5, and 8. So these would add to 13. So that would make this a 2, wouldn't it? Six plus 9 is 15. We'd have a 5, so this would be 5, 9. I think it works. 6 seems almost like it's destined to happen. So if this were a 6, this would be 9, 5. If this were a 5, we'd need 9, 6. I think that can go in any direction. If this were a 4, we'd need 9, 7. I think can also go in any direction. That wasn't that helpful. You're saying 9 is limited in the row. That would be nice. Let's see. What about here? These 9s line up, so it can't be here, but I don't see how you're eliminating 9 from here. The 4, 5 square? How are we going to get 4 or 5? Certainly not above it, not to its left, not to its right. So the 4 or 5 is it has to use below. Oh, that's really cool. The 4 or 5 has to be fulfilled below it, which means we can't put a 9 in any of these 3. And that actually intersects this row. So 9 can't be here or here because this 9 can't be in this box here. And these 9s line up, preventing 9 from there. So this is where 9 goes. This 4 then now, this 4, 5, 6 now can't be fulfilled below or above, so I guess it never could have been. So it's fulfilled to its right. Not since the puzzle was created. Worm being semantic on me. Wow, this is hard. I can treat this kind of like a Thermo, even if it's a 4. We've got, well, I don't know how to do that. I think there's a maximum value for this one. What do we need? We need a 1, 3, 4, 5, 6, 8. Let me just think about this for a second. I'm gonna good lift this. This can't be a 1. We can't put a 1 in this cage because this would be 4 max and we'd have to put a 10 with it. We can't have a 9 in here, so 7. We could do 7 plus 8 for 15. Okay, so let me think about this. This can't be an 8 because that would just immediately ruin things. Can't be a 6 because then we'd only see 2. Can't be a 5 because then we'd only see 3. Wait, there's a 9 here. We only need to see 3 of them. So it can't be 6 or 8, but it could be 5 because we'd see 5, 6, 8. That means this can't be 8. Sorry, I haven't been keeping up with chat. Let me think for a second. Can this be 6? We could do 5. We do anything, then 6. And then we'd see an 8 and then a 9. So that would fulfill 4. So I think it's these two that are somewhat restricted. Not that much, though. But I guess the question we could ask is where does 8 go? And I guess we always knew 8 kind of goes here-ish. Okay, 8 goes in one of these two, actually. That might be useful. We know 8's up here. Sorry, let me catch up with chat now. Row 6, column 7 can't be a 6. Where's row 6, column 7? You think this can't be 6? It would have to fulfill the 6 to the left. 1, 2, 3, 4, 5, 6. So all of these would have to strictly increase. But this can't. This would then have to be like they're the 9's over here, right? Okay. With the 9 being in one of these two, this has to be a 3 clue. So that's 3 and 6. What else do we see? Row 4, column 1 equals 6 actually does not work because a 2 in row 5, column 5 pushes 2 into row 9, column 6. And that skyscraper clue would break. So why don't we just go backwards here? Can this be a 2? We see the 9 in this direction. We'd have to put an 8 here. I see what you're saying. That's really interesting. So if this were a 6, we know this strictly increases, which means this is the 8. Because we need 1, 2, 3, 4, 5, 6. Okay. So if this is 6, this is 8. We know this would be 5, 8, which adds to 13. So we need another 2 to get to 15, which puts a 2 here. But the 8's used. This is 8, 9. We'd see at least one more. So this couldn't be a 2 either, and that would remove 2 from the 9 cage. So this is not 6. So what does that mean? That means This no longer can add to 15, so this can't be a 5. Don't know what else this means. Can this actually be an 8? Yeah, it can. We'd see 4 because of this 9 here. Well, so it could fulfill its 2 in some other direction, but it's not allowed to see 3 in any direction. If this is a 2, it has to see 1 or 2 in all of the directions. Row 2, column 4. Ah, this has to see 4 or 5, so this can't be an 8. That puts an 8 in the cage. But can this even be 6? I think so. 6, 7, 8, 6. Yeah, it can. That puts an 8 in the cage. So what does that actually mean? 8 with 2 adds to 10. We'd be with a 5. Let's do this. 8. 8 plus 2, that would be with 5. 8 plus 3 would be with a 4. 8 plus 4 would be with a 3. But this is a 2, 3, 4 triple, so this isn't 3 or 4. If this is 5, interestingly, we'd have 5, 8, 9. This would be a 4. So we'd only see 1 more. And this can't be 6. Let me do that again. If this is 5, that's 8. This cell now has to be a 4 because it can't be 5 anymore, so it's 5 in the row. It's already seeing 3, but it's going to see one of these 6s because this can't be 6. These can't be 5. Why can't this be 6? 9 plus 4 is 13. This would be 7. Oh, if this were 6, we'd only see 3. Wait. These can't be 4. What am I seeing here? So this can't be 6 because then we'd only see 3. If this were a 3, one of these is a 6 and we'd see 3, 6, 5, 8, 9. That's 5. So this is an 8. I guess is the conclusion there. So what did I do? Okay. You're saying that, oh, because the 6 would mask the 5. This is 5, 8. This is 4. This would be 3. We'd have a 6 in one of these. So we'd see 3, 6, 8, 9. Oh, that does work. Shoot, okay. So I can't make that conclusion. Oh, but we have the other issue. 5, 8 makes a 2 here. And now this can't be 2. Okay, that's a lot easier to see. So this is 8, but for a different reason. And this can't be 5 for the... Oh, this could be 5, actually. But of course an 8 here. Okay, I see what you guys are saying. I think I got it. So now, this is never seen. That doesn't really affect this clue, though. What can I do next? I'm wondering about this box. Like, I haven't touched it. Okay, let's look at this then. Can't exceed 4. That could be useful. So this is, it can't be 1 either, so it's 2, 3, or 4. That makes the 2, 3, 4 triple. We get the 1, 3, 8. Gives us this 8. Oh, that's cool. Should have looked at that earlier. This is not 9. This is 5 or 7. So let's look closer at this. This could be 2 if this were 6 of the height. Well, then what would we put here? If this were 2, this would be 6, 9. Or 9, 6. I guess it doesn't matter. But what would we do here? I guess we could just put a 7 here, and that would be 9, 7, 9. That works. Can any of these squares be 1? This can't be 1. Can this be 1? These would both be 9. Well, we'd have a repeated 9. 9 can't go here. Right, we can't repeat a 9, because 9 can't go here from the box. So one of the repeated 9s would have to be here. But then this one would be the repeat, and that's 8. So wait, if this were 1, yeah, it would see a 9 above it somewhere, and things before it. We can't block the 1 here. Okay, I think that's correct. So the 1 goes in the 12 cage. And the rest adds to 11 without a 6, 8, or 9. So we can't do 2, 9, 3, 8. We could do 1, 4, 7. We can't do 5, 6. So this is a 1, 4, 7. Which means this is not 4. Which means, okay, so these are 2, 3, or 5. That's not 3. Can this be 2? No. Because there's going to be a 9 up here somewhere. Well, I guess it could be, right? This can't be 8. Why don't I just place this 8 then? Maybe it could be 2? Seems hard. Obviously, these directions will just be fulfilled no matter what. The best I can do is put a 9 here. This can't be... Can this be 5? We've got 8s over here. I don't think this can fulfill a 5. That's not 5. So this is a 2, 3, 4 triple. So that's not 4. The 4 is up here. That gives a 2 and a 4. That makes this a 5. So neither of these are 5. This is not 5. So this 4 means there's a 4 down here. This is 2 or 3. That seems... Wait, where does 9 go in this column? It's one of these two. This one can't see 2. It could see... If this were a 5, it could see 3. Or if this were higher, this would be... Row 7, column 3, 5 clue. Where does the 9 go, I guess, is the question. The 9... Oh, wait. Has it just... This could be 9. This way? 1, 2, 3, 4, 5. Can't this be 9? And we do 1, 2, 3, 4, 6 or something? I'm not so sure about this 5 here. You're saying the 20 gauge can't do 4-7? Oh, that's a good point. Wait, is that true? Yeah. If this 20 gauge were 4-7, that would break this 1-4-7 here. We'd have too many 1-4-7s in the column. So this is actually 5-6. So these are not 5. If that's 3 or 4, then this can't be a 2 anymore. Wait, yeah, okay. This has been very difficult. Let's see. 1, 2, 3, 4, 5, 6, 9. I'm just kind of randomly filling stuff at this point, but 3, 4 pair means that's not 3, 4. Okay, how are we fulfilling this 5 then? We fulfill it to the right. This is 2 of them. So these have to strictly increase then. So this is not a 1. This is 6. This is not 1. That's a 3, 4 pair. So this is 1. And then no matter what this is, that fulfills it. 1, 2, 3, 4, 5. This is no longer 5. Or 6. So this is 2. Wait. I must have filled... I filled this wrong. I'm going to redo this. We need 2, 5, 7, 9. These aren't 9. This isn't 5. Okay. This is not 2 because of the 2, 3, 4. 2, 3, 4, 7. Can this 5 fulfill to the right, I guess is the question. No, because it can't put... Well, it could put a 1 here. But that would only be 4. So it can't use the 2, 3. Because it's going to put something bigger than 2, 3 somewhere here. And so it only has 4 cells to use. So the 5 is fulfilled up. So if this were a 7, there's no way we're fulfilling the 5. So this is still a 2. This can't be 7 either, can it? 5, 2, 7, 9 would be the best we could do. The 8's used. So 2, 7, 9 is only 3 cells. So that's not 7. So the 7 is placed. 3, 4 pair means this is... This is 1, 2? Yeah. Three, 4 pair means this is 9. So now 1, 2, 3, 4, 5. This has to strictly increase then. So this is 3, this is 4. That's 3, that's 4. The 4 is fulfilled to the left. So that's good. What's left here? Oh, this is 6. This is 9. So we need a 1. And then we need a 7. So now this is fulfilled. And then this is not 1 or 7. So this is the 4. Oops, this is 4. 1, 7 pair puts 2, 3, 4 up here. Is that right? And 4 must be in one of these two, so this is 5 and 4. This 4 sees down, so that goes here. This 4 is automatically fulfilled to its left. How about the 2, 3 though? Well, if this 4 is fulfilled to its left, it doesn't have to be fulfilled. Does it have to be fulfilled to its left? 3, 9. I don't know. I don't know yet. I'll look at other stuff. This is a pair. 1, 6. How many can this see up? The 7 is going to mask the 6, so we're going to see the 7 and the 9. So we could either do 1, 7, 9 to see 3, or we could do 7, 1, 9 to see 2. So I don't see how that resolves. Row 6, column 4. This 4 has to see... This 4 is fulfilled down. We saw that a while ago. If this were a 9... If this were a 9, then... This 1, 2 is not seen, so I'd only see 3. So this can't be 9. The 9 has to be lower. That makes a 5, 7 pair. The 9 has to be one of these two. You guys were talking about this guy? He sees 2 above. He sees 2 to the right. So he can't see 3 in any direction. Yeah, so that's 2, that's 3. This is a 2, 4 pair. This being 3 means we do have to do 1, 7. So we see 1, 7, and 9. That 7 sees here, that's 9. Places this 9 here. This is a triple. We need 1, 6, and 8. That's not 6, that's not 8. So this is 5, 7. This is 3. So this 5 or 7, no matter what, hides the 4. We could fulfill the 3 here by doing 5, 6, 7. This is going to see an 8. Oh, this is going to... Oh, wait, this has to be 9. Okay. So this 3 can't be fulfilled up or left or down. So it must fulfill it this way with 5, 7. That's a 2. Does that work? It sees 2 to the right. It sees 2 to the left. It has to see 2 up only, so this is 1. That's 6 and 1. 2 and 1. Does this 4 work? It doesn't see 4 down. It doesn't see 4 up. It sees 4 to the left. It sees 3 to the right. Okay, good. Do we have any other squares to look at? This 5 worked out. I think it's just probably Sudoku at this point. We have so few digits left. 3 and 6. Not resolved. Oh wait, these aren't 1, so this is 8 and 6. What do I need for this box? I need 2, 3, 5, 7, and 8. So this isn't 2 or 8. I'm missing something. 3. So this is 5, 7 pair. That's not 2, 3, or 8. 5, 7? Okay, so this is 7, 5. It sees a 3 as well. That's 8. Yeah, very nice puzzle. That was difficult. Very intriguing rule set as well. Four and 2. All right. Very intricate. All right, thank you, Dr. Ecke. Give me one moment. I have to go to the bathroom pretty bad, so I'll be back in a second. I have returned. Sorry about that. All right, we'll do one more, and hopefully it won't go over too much, but it's Saturday, so not a big deal. Did I get the quadruples? Did you request German Whiskers, Jessica? See, 1, 2, 3. We've done 5 puzzles, yeah. So we're on our 6th one. I did get quadruples. It's pretty close to my queue. Why don't I see German Whiskers in my queue though? Alright, we'll do Jessica's. I don't know why it's not in my queue. Can you resend it, Jessica? Can't find it. Yeah, please do. The animals want me for something. They're gonna have to wait. Alright, we got the link here. One moment. Alrighty, let's get this done. So this is called German Whiskers. It's by Jessica Shaham, my sister. This is pure nepotism. No, Jessica makes very good puzzles. So obviously it looks like a cat. That's really cool. And the German Whispers lines are whiskers. So we have German Whispers lines. Basically, adjacent digits along the line must be 5 apart or more. They have to have a difference of 5, at least 5. We have normal Thermo rules. So this is the only Thermo on the puzzle, and it branches. But digits have to increase from the bulb end. So if I put 3 here, this could be 5, and then 7, and we can put 8, 9 at the end here. And then the 2 circles that are not the Thermo bulb must be odd. So this one does not have to be odd, don't get confused. But these 2 do have to be odd. So let me give you the links. And this is opportune time to bring on an expert. Here's our expert on German Whiskers. Yeah. Okay. Kitty. Kitty's here to distract you from my poor solving. So we can start by good lifting the odd numbers there. What's wrong? She's very upset about something. This is Claudia, spelled C-L-A-W, because she has claws. I don't know what's wrong. You can see her whiskers. So I like to color the Whispers lines to represent moving between every other 1 to 4 and 6 to 9. We don't actually, we're going to use 2 different colors here though, because we don't know how they're linked yet. And then we'll adjust the colors once we do figure out how they're linked. This Thermo, this could be 98765. So this is, let's do it. Let's do this. Did I screw up my colors somehow? That's every other... Ah, this one. There we go. What's wrong? She's very upset about something. Okay, so... Yeah. 5 never goes on a Whispers line because you can't do a difference of 5 with 5, so that forces 5 here. And so now we got... Oops. This Thermo's done. Almost. Just like that. 8 goes on this line somewhere. The other thing about German Whispers lines is 6 and 4 are quite limited. Row 6, column 9. Yeah, so now 5 can't be here, so this is 5. 5's up here somewhere. So I don't know if that's relevant here. Let's see. Like, you can't put a 6 or a 4 here, because it would have to be surrounded by a 1 or a 9 in both directions. So this is, but we don't know if this is low or high yet. What? Okay, so I think this row 6 might give away a lot, actually. We've got 3 oranges. We could only have 4 of a color in a row. So that means green is actually not orange, because then we'd have 5 in the row. So green is blue and purple is orange. And then we have a 6 already, so we actually know the lows and highs. These have to be the 7, 8, 9 highs, so that we can have 1, 2, 3, 4 lows here. So that places the 8. And I apologize, but I'm very used to blue being low, so I'm just gonna swap these out real quick. There we go. So now this is what I'm used to. Can't put a 4 here because it has season 8. So these are from 6, 7, 8, 9. Now these can't be 6. And that can't be 6. So the 6 goes here. So that has to be 1. I'm gonna just put my camera back up here. Well, let me see what I can get from here first before I move on. Can this be 4? it would have to have a 9 in all of these. There's no way this is 4. Even 3 would require 2 9s and an 8. Okay, you know what? You're complaining too much. Let's see. Oh my gosh. I should not have left my door open. I feel like there's probably more I can do here. Like this can't be 4. Wait, yeah, because these can't be 6. This can't be 4. Wait, no, 4 goes to 9. What am I talking about? This. Can these both be 9? This can't be 4, because these can't both be 9. So this is 4. So that's 9. These aren't 4. This can't be 4 because that can't be 9, so that puts the 4 here, so that's 9. Let's actually fill this. This can't be 6 because that can't be 4. No, wait. Thinking about that wrong. These can be 1. So this can be 6 or 9. Nice. This can't be 3. Neither can this. Because it sees an 8. Wait. What am I talking about? Can be 3. I don't know why I thought that couldn't be 3. We've got a given 2 here. Given 3 in the box. Okay, so this is 1 and 2. Oh, it couldn't be 3 because of the given. That's my story and I'm sticking to it. Let's see. So 2 over here. Five in row 2. Ah, yeah, these 5s conveniently look up into here. So that places this 5. These odds haven't done much for me yet. What do I need left here? I need 3, 4, 6, and 9. So these can't be 9. So there's a 9 in one of these two. Which means there's a 9 right here. I need water. Six. Oh yeah, 6 would require a 1. So yeah, this has to be 9. It could have been 6 up until I removed the 1 from here. Wait. I just didn't decide. I decided 8 wasn't a thing. Anyway, wait. What? Not 8. What am I missing? 5? 5 goes somewhere? Not here. So 5's in one of these two. What am I doing? this were a 3, these would both be 8. Why is that a problem? These would both be 7. That would be 1, 2. This 7. Put a 2. That's okay, yeah, that's quite the... There's probably something easier to do. But if this were 3, these would both be 8, making both of these 7. And that removes 3 from the rest of this row. I guess another way to put that, probably an easier way to see that, is one of these is a 3, which means one of these two is an 8, which means one of these two is a 7, which means we have to have a 2 here. That's probably an easier way to put that. That puts a 2 here. These twos look down. These twos look over. That doesn't do a whole lot. Two's one of these 3. So we have 1, 2, 3, 4, 7, 8, 9. Yeah, so this is a naked single. Whoa. What is it, a naked single of? 1, 2, 1, 2. It sees 1, 2, 3, 4, 5. Oh, it's a naked single 6. Got it. So that's a 3, 4 pair. This is a 5, 6 pair. This sees a 4. So this is 3. This is 4. Right, Whiskers completable. I believe you, but I don't see it. Oh, this 2 makes this a 3. Oops, that puts a 3 here. 3 must be with... 3 can't be with 7, so that must be with 8. So that's 7. Nine, 8, 7, 8. And then we've got 1, 4, and 9. That's not 9. This is 1, 3, and 4. 3 goes here. One, 2, 3, 4. This is 5 and 7. And this is 2, 3, and 8. Not up. This column, we need 1, 2, and 9. That's not 9. So the 9 goes here. These can't be 9. Maybe I should look at these lines here. So these 4s look up. Can't put a 4 on the whisper line in the middle of the line, so the 4 goes here. This is 2. So what's left here? We need a 1, 3, and 6. You can't put a 6 here either, so there's a 6 in one of these two. This is 1 or 3. If this were a 6, this would be 1, 3. It's not a 6, this is 6. No, that's not. We got it. These can't. This can't be 1, 3 because it's a whisper line. So that's 6. That's 1. That's 3. This is anything high, so 7 or 9. It's not a 9, so that's a 7. There's no 7 here. One's one of these two. Do I have anything else? This 2C's here. That's 8, 3, 2. So there's a 3 in one of these two. Hey, Peter. Six looks up here. Must be one of these two. So 6 over here. That's not that useful. What am I missing here? Eight. One of these two. Did I just type 5 instead of 8? Did. Okay, this row. Let's do it. 1, 3, 4, and 9. Yes, 1, 3, 4, 9. This isn't 1 or 4. Or 9. So this is a naked 3. Found something. If that's a naked 3, this can't be 9, because it has to whisper it. So 3 plus 5 is 8. This is 8. This is not 8. 8 can't go with 4, so that's a 1. This is 4, this is 9. This is a 3-5 pair. So this is 4, 6, and 8. We know where the 8 goes. This is not 9, so the 9 goes here. 5, 6, 4, 5, 6, 1, 2. I feel like I have too many. 1, 3, 4, 5, 6. The 1 here. This is 4, this is 1. 4 and 1. Again, I have too many. Why am I not able to scan this? 3, 4, 5, 6. The 3. Here we go. That's 5 and 3. 6, 5. 4, 6. I think this is just finishing at this point. That's a 5. I need a 1, 3, and oh, I trusted my marks a bit too much there. Let's just fill this. We need a 1, 6, and 7. Okay, so these can't be 1. So that is 1, and this is 6 and 7. I need 1, 2, 5, 6, 7. 1, 2, 5, 6, 7. Yeah, these aren't 1 or 2. This has to be the 5. So this is 6, 7. This is actually the 7. This is 6. These are not 6 or 7. This isn't 2 or 1. That's not a 1. So that's 2. That's 1. That's 5. 1, 2, 7, 5. We're finishing. I need a 4. I need a 6. And I need a 7. All right. Well, thank you, Jessica. 21 minutes. Perfect timing. Yeah, I suppose removing the colors would have helped. That's a cat with gas. Nice. All right, well, this is the perfect time to end the stream. Thank you everyone for coming. Thank you to all the constructors and everyone who helped in chat. You want me to remove the colors? Okay, there you go. Now let's all rush off and watch Simon's awesome video. Appreciate all of you. Please remember to subscribe if you're not subscribed. If you're new to the stream, Please do subscribe. I am trying to get to 1,000 subscribers. That is a special threshold for YouTube, which unlocks all sorts of things, all sorts of goodies for me. I'd love to reach that goal. So tell your friends to subscribe as well. I hear my stream is very nice to fall asleep to, so even if you don't like Sudoku, maybe that's something to subscribe for. And as always, thank you for watching. And I will see you guys on Thursday, if not earlier. Bye.